Today we're going to send and receive UDP packets or datagrams in C. Welcome back. In my last video, I talked about the two main kinds of sockets we use in network programming, that is stream sockets and datagram sockets. I, of course, have posted videos that show you how to use stream sockets in the past. So today I wanted to play around a little bit with datagram sockets. We're going to send, we're going to receive, basically using the UDP protocol, and we're going to show you how to do this in C. This video, of course, will contain source code, and as always, source code is available through Patreon. A huge thanks to all of you who help support this channel, help make it what it is, either through supporting the channel directly through Patreon or buying merch or just telling friends. However you help out, however you spread the word, I really appreciate it. Okay, now let's look at some code. So we're going to start out here with a fairly minimal program, just a little bit of starter code. We have some header files up here at the top, and we have a main function that's currently just checking to make sure it has the arguments it needs. So this is the way the program is going to work. We're going to, of course, the name of the program here, and then we're going to pass in the IP address that we want to send a packet to, because we're going to start out with sending, then we'll do receiving in a separate example. Yeah, so we need an IP address, we need a port that we're going to send to, and the message that we're going to send. So nothing too complicated, we're just sending a packet. This program is going to do one thing, it's just going to send a packet to an IP address and a port, hopefully where there is another program listening on the other side. And don't worry, we are going to write that program too. Just stick with me. Okay, so the first thing we want to do in here is we are going to, we're going to try to get some information about our the peer process that we're sending to from our args. Okay, so what I want to do here is just make some variables because I don't want to keep referring to argv2, argv1, wherever throughout the program. So let's just come in here and say we're going to have a const character pointer. We'll call it peer IP, and we'll set that equal to argv1. And then let's make an int. That's going to be the port. And use ATOI to grab argv2. We'll convert that to an integer. Now, I'm not checking for errors here. I'm just assuming that you'll pass in an actual integer, but we could check for errors here if we wanted to. I'm just going to keep this simple. And then let's have another pointer, which is our message, and that's going to be equal to argv3. Okay, so we've got our three variables that are basically just representing our arguments. Now, one thing I want to point out is that here we are passing in the IP address as a string. So this is the human readable format or printable format. This is not the format that our socket operations, our socket functions are going to need. So we need to get it into that form. So what we're going to do is we'll come down here and we will we'll declare a struct that is a sock adder in, and we'll call this peer adder for peer address. And then let's just initialize this. So there's a few things I'm going to need to set. So one is this SYN family. We're going to set this equal to AFINET. That is address family internet. So we're going to use this for IP version 4 or IPv4 addresses. If you wanted IPv6, you would use INET6, but I'll stick with 4 for right now. And then we will set the port. Now here we would be tempted to just say peer port like this, but because not all machines use the same byte order, we need to say HTONS. That is host to network short. So that is basically converting the native host byte order to the network byte order, and it's for a short because ports are shorts, 2 bytes. So we've set those two things here. Why didn't I set the IP address? Well, because like I said, it's human readable. We have to convert it. So what I'm going to do here is say, let's just check. So we're going to use this INET PTON function. So this is short for, of course, INET is internet, and then printable to network format. So we're going to take the printable form, which is what we have. We're going to specify that this address is going to be AFINET again, because this is internet addresses. And then we're going to pass in our peer IP. This is just the string. And then we're going to pass in an address, the address of, or a pointer to this peer adder dot SYN adder. Okay, so this is the actual address structure here. And I'll just add those parentheses to remove any confusion that may be caused about what's actually going on. So what we're doing is we're specifying in this little struct, we have an address member, and then I'm taking the address of that. So this function right here is just going to convert the printable version to the binary version that the socket functions are going to use. So we're going to do this. And let's see, if that returns something that's less than or equal to 0, then we had an error. And so let's print out a quick error message. Something wrong with the IP address. And let's just return exit failure. Okay, simple enough. Okay, so now if our program has made it this far, we now have our address in a form where we can actually use it. So let's do something with it. And what we're gonna do is create a socket. We did this before with stream sockets, only we're gonna do it slightly differently here. So let's make an int, and I'm gonna call it UDP socket. You can call yours whatever you want. And then I'm going to call the socket function to create a new socket. We're going to, again, AFINET is the protocol family, the address family we're using. And I'm gonna specify that this is a datagram socket. So sock dgram, where before we used stream sockets, we created stream sockets. And then this third argument is a protocol number, okay? Now, in many cases, as the case here, many cases you only have one option. So if we're creating datagram sockets in this Linux distro and I specify 0, that's like just use the one that we always use, or maybe it's the only one that's available. That's often the case. If you're in a system that has multiple different protocol options, you may have to look up the protocol number, and let me know if you want to see a video on how to do that. There are ways to do that programmatically, but that's something I'll save for a future video maybe. In this case, this just specifies that I want a UDP socket, and then let's just check if UDP socket is less than 0. So again, we're just doing error checking here. Then we're going to print out that something went wrong. Sorry, couldn't create the socket. And again, let's return exit failure. Okay, so at this point now we have moved on. We've now created our new socket. We have our socket in hand. We're ready to do something with it. So the next thing we're gonna try to do is actually send a packet. So for that, what I wanna do here is we're gonna use send to. So before we use send, if you have a stream connection, you would use connect, you set up the connection, and then you just use send, and that just sends on the current connection. In this case though, because we're sending datagrams, we actually use send to, and we're going to specify the address that we are going to send to, right? Because we don't have a connection. There's no notion of connection in UDP. We're just sending individual packets to some address. So we're going to use send to, okay? So send to, what we're going to pass in first, let's pass in the socket that we created. Then we're going to say, this is the message. Right now, I'm just going to send the message as the payload. And let's say string length message +1. That's just to make sure. I'm going to send the null terminator as well. That's why I'm going to specify +1. 0 is it's for some flags. We'll maybe visit that in a future video, but for now, just, the default is 0. And then last of all, what we need to do is pass in the address. So that's just the address of peer adder. Okay, so you've got this address, this sock adder instruct that we're passing in, and we're going to pass in the size of peer adder. Okay, so this is the function we're going to use to send our UDP packet. Let's just do some error checking here, make sure it actually works. So we'll say if this, and we'll come down, and let's just check to make sure that it's not negative. If it is negative, then something went wrong. And then if something did go wrong, then we will call p error again and say failed to send message. And then in this case, I am going to do a little cleanup. I'm going to close my UDP socket. And then as usual, we will now return exit failure. Now note that in your own programs, in my errors here, I'm just exiting the program. That's fine if that's what you want to do. In your own programs, you can do whatever you want. So you could try again. You could also print out some helpful advice on how to address the issue, whatever the error happened to be. This is just what I'm doing for this example. And now we've actually sent our packet. So the last thing I want to do is to come in here and we're just going to print out some status. Basically, this is a victory message and we'll just say printf sent, and let's print out the message to, and then I'm going to say this is the IP address and the port, and then let's pass in message and peer IP and peer port like that. And then, now that we're done, let's just close our UDP socket. That's just telling the operating system, we're done with this. We don't need to send any more data using the socket. So we're just releasing that network endpoint. And now, as we did before, we're just going to exit. So yeah, so this is all there is to it. Now let's make sure this actually works. We'll come down here and we will compile. Okay, so this is one issue that you might run into. It's just a warning. You know I don't like leaving warnings floating around. And because on some systems I don't get any warnings, in some I do. So, you know, if you want this warning to go away, really it's because there's some overloading going on. Different protocols have different address structures. So what I'm gonna do here is just come in here and say struct, we're just gonna cast this to a sock adder. So there's this more generic sock adder structure that can be used interchangeably for lots of different protocols, but it turns out because I am using AFINet, I really do want to pass in a sock adder in, but this should make that warning go away. Yeah, there we go. And sorry about the clock skew warnings. Anyway, I need to fix my Vagrant install, but that's something I'll do after I'm done recording this video. But so now if we come in here, we have UDP send, and we can just say, so let's use the 127001. That is our loopback address that'll send to something on the same machine, because I'm just going to send to a process on my same machine. Let's pick a random, let's say 9800 is the port we'll use, because why not? And then let's say here is a UDP datagram. Okay, so it looks like it ran correctly, at least it thinks it did. Now, how would we know if it really did? Well, we could get out a packet sniffer. Let me know if you want to see how to use a packet sniffer like Wireshark in a future video. That would be one way we could check this. But another way to check it is to actually write a program that receives the packet, which is what we'll do right now. So for this, let's jump over here to this UDP receive.c file. For this one, we're starting in about the same place we did before. We've got some header files up here. We have main. There is this function right here. I'll explain really quick what we're doing here. I basically added this check function. It's down here below. One thing you may have noticed in the last example was that there was a definite pattern to our error checking. We were doing the same thing over and over again. Each time we were checking usually for a -1 or a negative value. Most of our socket functions will return a -1 if they have an error. So we were just checking for that socket error, and then we were exiting after printing out a message. So I decided to just make a check function, which is just going to basically check some result, see if it's equal to socket error, and then handle our messaging with P error and exit if there was an error, and otherwise we just return. Okay, so nothing fancy there. I just thought that might be useful, just to show you another way to do this. Okay, so now let's come down here. Again, we're just checking our arguments. In this example, you notice we're just running the program with a port number because you're just listening on the local address. So we don't need to specify the IP address, and we don't need to specify a message because we're not sending anything. We're just receiving and printing out what we received. So the first thing I want to do is come down here and let's just say, let's make a variable called myPort, and I'm going to save that from argv1. So we'll convert it to an integer. Again, I'm not doing error checking on this. I'll just assume that you got that figured out. The second thing I want to do is to come down here and declare my, I'm going to need a socket for the receiving. So UDP socket. And maybe just so we don't confuse between the two, I'm going to say UDP RX socket because it's a receive socket. RX, by the way, if you haven't seen that, RX is a common shorthand for receive. And then I'm going to need two addresses. So the first one we'll do, so struct sock adder in, just like in the previous one. So I'm gonna have one for the peer address, just call it peer adder. So this is going to eventually get the address of the person that I'm receiving data from. And then we need another one that is my address. We'll call it my adder. And this one, let's just initialize it like we did before. Family is AFINet. And then we will come down here and say the adder.sadder is inadder any. Okay, so what that's saying is, let's say this machine had a bunch of different addresses that we could listen on. This is basically saying just any IP address that I have available, I'll listen on. And then let's specify the port as well. And again, we need to go host to network short, just like we did in the last example. Okay, so now we have our address. This is specifying how I want to receive. I want to receive from any of my addresses and internet, and this is the port I want to listen on or receive on, because we're not calling the listen function, so I don't want to confuse anyone by using that word. We're not calling listen with UDP datagrams. We're just going to be calling receive from, and that's going to wait till we get a packet. Okay, so finally here, let's declare a buffer. Okay, so this is going to be, let's just call this buffer, and we'll say it's going to be buffer size, which I haven't defined. So maybe we'll come up here and say pound define buffer size, and just give something big enough that'll work. 1024 should be plenty. I'm not going to send anything bigger than that. But this buffer is going to hold the packet that we're receiving. So we just need someplace to stick our packet. Okay, so now we have our variables set up. Now let's create our socket. This is just like before. You're going to come down here and say UDP RX socket equals socket AF INET. Again, it's a data. And so let's do some error checking. Let's put this whole thing in a if statement, and we're going to check to see if it's less than or equal to 0. And we will print out an error message. So just like before, key error, fail to create socket, and we will exit, and we will return exit failure. So that's pretty much the same thing that we had before. Now things are going to differ just a little bit. So specifically, let's come down here and we're going to need to bind our socket to the address that we want to receive on. So here we're going to bind the socket to the address, and most importantly, or more importantly, the port. That's really what we're focusing on here. But so yeah, so the idea, let's make a variable called result, because I am going to care what this returns. And let's call bind, and bind will pass in the UDP RX socket. So just our socket that we're using for all of these things. And then again, we will say my address, my adder. So you remember I defined that up here. This is the one that specifies what we're actually, how we're listening, what port we're listening on. So we're going to do this. Now, once again, there is that warning concern. So I'm going to come in here and cast this to a sock adder pointer, just to make sure I don't get that annoying warning. And then we will specify the size of my adder. Okay, so the size of the address, so we got the pointer, the location of memory that holds the address, and the size of it. And don't forget the underscore. And then let's do error checking. So this is just to show you how to use that little check function down there. I'm just gonna say check result. So if result happened to be equal to socket error or -1, then we would just say could not bind socket to address, and this would exit. Okay, so now that we have our socket bound to the address, we can use, instead of send to, we're gonna use receive from. So we're going to use the receive from function. It's just sort of the other end of send to, and we're going to use that to receive the packet. Okay. So here what we're going to do is we are going to pass in our UDP RX socket. We're going to pass in the buffer that we want to store the data, whatever we receive. We want to store it into buffer, and we'll pass in buffer size to tell us, yeah, that's as many bytes as you can put in. And then receive from is also going to give us the address of wherever the packet came from, because we don't have a connection again. So it could come from anywhere. This could be coming from the other side of the world, or in this case, it is going to be coming from the same virtual machine that we're running on. But just so you can see how that works, we are going to, again, I need that cast struct sock adder pointer, and this is going to be peer adder. So this is going to be the address. You know, before we passed in this what represented my address that I'm listening at. This is the address that the packet is going to be coming from, and we are going to. Ooh, actually, I forgot an argument before I do this. Before I pass in the address, there is also a flags argument that goes right there. Sorry, just skipped right over that one. Today we're sticking to the basics, so no flags, but we do need the argument there. But yes, then comes our address, and then after that we have the length of our address, or the size of our address. So it'd be nice, it'd be tempting to just be like size of peer adder, but that's not really going to work, because what's happening is this is actually, because we're getting this pointer back, this actually is going to be filled with the value of the size. This is going to represent where the function is actually going to store the new size in here. So this needs to be a pointer. So what we're going to do is, let's make a new variable here. We're going to call this socklen t, or socket length t. This could probably be an int, but then we would have to cast, and I'd love to not do that. So we'll call this address length, and I'm going to initialize this to the size of peer adder, because that is what we're passing in. But then here we're just going to pass in the address of address length. And so that allows the function, the receive from function, to change the value of address length if it decides to. And so that is receive from. Now receive from is going to return the number of bytes received. So let's just say here, bytes received equals, okay, like that, okay. And then once again, we will call check bytes received, and we'll just say, sorry, receive from failed. Okay, so at this point, if we have got to this point, then we ran receive from returned, basically meaning that we think we received something. And I want to emphasize that the way receive from is going to work is it's basically just going to block. It's going to sit here and just wait until a packet comes, and then it will return. So it could wait a very long time. If for some reason we don't want it to wait a very long time, we can set timeouts. Again, I'm sticking to the basics today, but let me know if you'd like to see a video about setting socket timeouts in the future. That's something we can definitely cover just in a future video. But for today, what I'm going to do is just come down here and let's just, again, print out something, letting the user know that actually something worked. So we're going to say received a packet from, and we'll use the same format we used before. So IP address and port, and then let's say message equals, and we will just pass in the string that was received from the packet. So we're just trusting that this is going to be that the packets we're receiving are well formatted printable strings. If this turned out to not be true, we would get garbage, but for this demonstration, I think it will work just fine. And then let's pass in, we would like to just say, hey, peer adder, but again, that's not going to work like before. So instead what we're going to do is we need to call inet ntoa. So this is, again, I'm not sure why it's not NTOP, but it's NTOA. It's basically taking the network representation of the address and then giving us a printable address. So here we're going to say peer adder.syn adder, and then NTOHS. So this is the opposite. Remember we did HTONS, which was host to network short. This is network to host short. So it's like you received a peer that's in network byte order. We need to get it to host byte order to make sure that it doesn't get flipped and confuse us. So here we put peer adder.syn port, and then the buffer, which, like I said, is assumed to be a string. So it better be. And then once we're done, after we print that, then we are going to simply just close our socket. And then, oh yeah, we already have our return exit success down here. Okay, now I hope this works. Let's see, let's make sure it compiles. Okay, it looks like it compiles without any problem. So great, so let's test it out. So if we come down here and I'm gonna start my UDP receive program first, and let's say 9800. I think that's the one I used before. If not, it doesn't matter. We'll make sure we use 9800 from here on out. So now, like I mentioned before, when I run it, it's just going to sit here and wait. It's just waiting for a packet to arrive. Okay, so let's just jump over into a different terminal here. And what I'm gonna do is just do UDP send. And again, we did 127.0.0.1, 9800, and hello, this is a message sent over UDP. Okay, so it says it was successful. Let's see if it was. Okay, sure enough, over here it says we received a packet from our local machine, and this is the port that it was sent from, which was just randomly, like it wasn't bound to that port or anything. It's just randomly assigned. And then you notice that this is the message that we sent. It was received. And of course, there is a lot more we could talk about in terms of network communication, how UDP works, some of the different ways, like I mentioned, timeouts, different flags. Let me know if you want to see any of those in future videos, but I hope this is helpful. Hope this gets you started on your journey to sending lots of datagrams in all sorts of different directions. And as always, I hope this is useful in a future project. And until next time, I'll see you later.